Hello, my name is Siddesh Patil and I will be explaining multiplier circuit using the TI board. So here you can see at channel taking 1 kilohertz frequency and 1 volt peak to peak. On channel 2 we are giving 10 kilohertz frequency and 2 volt peak to peak. Here as you can see we are taking plus minus 10 volt PCC on the TI board. Here is the power supply. On X1 we are taking channel 1, on Y1 we are taking channel 2. The negative terminals of all are grounded. The Z1 terminal here is connected as feedback to the output. uh, here you can see the output, the 10 kilohertz frequency wave is carried by 1 kilohertz frequency wave. Here you will see FFT. As you can see on the cursor, we are getting the 11 kilohertz. We have taken 1 kilohertz and 10 kilohertz, so we should get F1 plus F2 and F1 minus F2. So we are getting 11 kilohertz peak wave and another peak wave on 9 kilohertz.
My name is Pavitra Chandwane and now I am going to explain the differentiator circuit that we made in which we'll use the multiplied signal. Resistors, we have used a 1.8 kilo ohm resistor and a 47 nanofarad capacitor, which will give us the roll-off frequency of around 11,800. And see, this is the differentiator circuit that we have made. We have taken the input from the multiplier signal and we have given appropriate plus minus VCC, and now we are checking the output over here. As you can see the FFT, in the FFT there we can see a major difference between the two frequencies gain, as we can easily able to differentiate the 11 kilohertz frequency and the 9 kilohertz frequency, as 11 kilohertz frequency has a gain of minus 27 dB, whereas the 9 kilohertz frequency has gain of around minus 32 dB.
I am Power Cycle, and now we are going to observe the two outputs. One of the multiplying two inputs, and one is the after we pass it through the differentiator circuit. We made the blue signal is after the multiplying, whereas the yellow one is after we pass it through the differentiator circuit. And you can see the differentiator in amplitude because there is some gain equals to omega CR which happens to the signal after we pass it through the differentiator circuit. Now we are going to compare the FFT of the sinusoids. First we have observed the multiplying circuit. As we can see, the amplitude for both 9 kHz and 11 kHz is almost the same, implying that we haven't separated the frequency yet.
Stop.
Now we will see the FFT of the differentiator circuit. As we can see, there is a minor difference in the amplitude of the 9 kHz and 11 kHz frequency, and implying that the differentiator circuit was able to separate out the dominant frequency. We were not able to completely separate the dominant frequency because they were too close to capacitor, and also due to unavailability of resistors and the capacitor for the required roll of frequency.